The inverse of log base 10 is y equal 10 to the x. All right, the inverse of a log function is an exponential function. For that reason, you could say 10 to the log base 10x is equal to x, and the other way around, log base 10 of 10 to the x is also equal to x, just because the two are inverses. Now, ln x is the same as log base e of x. So the inverse of ln x is y equal to e to the x. And again, e to the ln x is equal to x, and ln e to the x is equal to x. I'll do a quick sketch of y equal ln x so we can see what the domain and the range are. So y equal ln x looks basically like this. Let me mention ln 1 is equal to 0 because e to the 0 is 1. So ln x goes through 1 comma 0. It has a vertical asymptote at the y-axis, and it goes up slowly on the right. So the domain is x greater than 0. You see this graph is to the right of 0, and the range is y greater than minus infinity and less than infinity. In number 4, let's graph y equal ln x plus 1 minus 1, and then we'll find this information. All right, so we'll start with y equal ln x, and we saw what that looks like before. Y equal ln x goes through 1, 0, vertical asymptote on the lower half of the y-axis, and it goes up slowly on the right. We'll start with the translation left 1 and graph y equal ln x plus 1. So everything is moving to the left 1, so 1, 0, subtract 1 from the x-coordinate, and that moves to 0, 0. This vertical asymptote at x equals 0 is going to move to x equal minus 1. And so we get this picture. And now we're going to do the vertical transformation down 1 and graph y equal ln x plus 1 minus 1. So this point 0, 0, so this time we're going to subtract 1 from y, and we get 0 minus 1. So we actually get the y-intercept. The vertical asymptote remains the same, x equal minus 1. So we just have to find what this point is, this x-intercept. So we found the vertical asymptote by drawing the graph. We found the y-intercept, although I think we'll find that algebraically as well. Okay, so let's start by finding this point. We want to find the x-intercept. So to find the x-intercept, we set y equals 0 in this equation. We have 0 equal ln x plus 1 minus 1. Add 1 to both sides. Exponentiate both sides because the exponential function base e is the inverse of ln. So when we do that on the right-hand side unravels and we just get x plus 1. On the left side we have e to the 1, just e. Now subtract 1 from both sides and we have x is equal to e minus 1. Now e is approximately 2.7. You can approximate, let's say, by 3, so e minus 1 is approximately 2. But we're going to write here, for the x-coordinate, we'll just write e minus 1, 0. So that's the x-intercept. Okay, so that's our x-intercept. And we see this is the y-intercept, but let's find it algebraically as well. Let's say for the y-intercept, we set x equals 0 in this equation. And so we have y equal ln 1 minus 1. Ln 1 is 0. Sorry, ln 1 is 1. So that's 1 minus 1 or 0. So we have y equal 0 for the y-intercept. Sorry, ln 1 is 0. Let me correct myself. Ln 1 is 0. Okay. And so we have 0 minus 1, and for the y-intercept we have y equal minus 1, like we found over here, minus 1. Okay, we see from the original graph, ln x goes through 1, 0, so ln 1 is equal to 0. Let me just emphasize another reason why ln 1 is equal to 0. If we put this in exponential form, this is log base e. So take the base e, raise it to the exponent 0, e to the 0 is equal to 1. So ln 1 is equal to 0. I think now we have all the information we were asked for. We have the x-intercept, y-intercept, and the vertical asymptote. Number 5 asks for the value of e to the ln 7. So let's just remember again that the exponential function base e and the ln function are inverses. So this is simply 7. In general, e to the ln x equals x. And for the same reason as in number 5, the exponential function base e and the ln function are inverses. So here we just have 5. In general, ln e to the x is equal to x. All right, in number 9, we're going to write 1 over square root 27 as in base 3. So let's do that. So if we change this to an exponential, we could write, using exponent x, we could write 3 to the x is equal to 1 over square root 27. And so we want to put the right-hand side in terms of base 3. So we notice that 27 is 3 cubed, and we can write the square root as exponent 1/2. So in the denominator, we have 3 to the 3/2. And finally, 3 to the 3/2 in the denominator is 3 to the minus 3/2. So x is negative 3/2. In number 8, we want to write this expression as e to an exponent, because remember ln is the log base e. Okay, so let's do that. So this is equal to e to the ln e to the 1/3 divided by e to the 4th. So this is ln, just subtracting exponents, e to the 1/3 minus 4. All right, let's just do this. This is ln e to the 1/3 minus 4 over 1 is the same as 12 over 3. So this is ln e to the negative 11 over 3. And so this expression is equal to minus 11 over 3. In number 9, we want to write this as 0.001, can be written in terms of 10 to an exponent. So let's do that. So this is the log base 10. 0.001 is 1 over 1,000. So this is log base 10, 1 over 10 cubed, or log base 10, 10 to the minus 3. Okay, so this is equal to 10 to the minus 3. Sorry, not 10 to the minus 3, but minus 3. Just minus 3. Again, let me emphasize, since log base 10 and the exponential function base 10 are inverses, in general, log base 10, 10 to the x is equal to x. In number 10, let's set this equal to x and write this in exponential form. Base to the exponent, that's 1/2 to the x, is equal to 16. Let's write 1/2 as 2 to the minus 1, so we have 2 to the minus x is equal to 16, and we can write 16 as 2 to the 4th. So now we have minus x is equal to 4, and x is equal to negative 4.